Let's look at one more of these vector valued functions. So let's say I want to sketch the space curve represented by the vector valued function r of t, which will be 4 cosine ti plus 4 sine tj plus tk, where t is restricted to 0 to 4 pi. So we're going to look at our parametric equations for this. So if I separate out, here I have the part in front of I would be x, so x would be 4 cosine t, and then y would be 4 sine t. And if I take x squared plus y squared, what would this equal? 16 cosine squared plus 16 sine squared. If you factor the 16 out, you'll be left with cosine squared plus sine squared, which we know to be 1. So I'm getting the equation x squared plus y squared equals 16. And this is a rectangular equation. Right? This is a rectangular equation. And what is it the equation of? It's the equation of a, in space, it would be a circular cylinder. So my curve lies on a right circular cylinder of radius 4. The square root of 16, so the radius would be 4, and it would be centered about the z-axis. So let's go ahead and draw a right circular cylinder. Okay. I have radius 4. So I'm going to try and draw a circle here. And then it goes up the z-axis. So I know that my curve lies on the cylinder, but let's look at our z-coordinate. Our z-coordinate was equal to t. And remember that what does t do? T increases from 0 to 4 pi. So what's happening is as t increases, my curve is getting higher up on the cylinder. So what's going on is that this curve spirals up the cylinder. So if I plug in 0, you'll see that my curve is going to start right here, and then it's going to go around. So it's going to climb up the cylinder, and as it's climbing up, it's going around the outside of the cylinder. It's going to stop right here at the point 404 pi. And it started at the point 400. So this kind of path, let me fill it in so we can see. This is the curve here. We went around the circle, but as it goes around, it's going up and up and up. And this is sometimes called a helix, because it's spiraling up this cylinder. So now I want us to look at kind of a different question. In the previous examples, we started with a vector valued function and asked what the curve is. We could flip that and start with an equation, a curve, and ask what would a vector valued function for that look like. So let's represent the parabola y equals x squared plus 1 as a vector valued function. So I'll start by saying there are many ways to do this. There are many different vector valued functions that draw out the same curve. Just like parametric equations are not unique, vector valued functions wouldn't be unique. And so one easy way to produce a vector valued function for this equation would be to say, let x be t, and then you're going to write your y equation in terms of t. It would be t squared plus 1. And so one vector valued function for this curve would be ti plus t squared plus 1j. Again, this isn't the only way to do it. It's just one of the easiest ways to do it is just let x be t and then plug in t into your y equation to get your other parametric equation.